Alright, so this is scan and solve. It's used to, so you can manipulate your object by uh, putting forces onto it, and it's used to simulate deformations, identify stresses, and can be used to check for failures. So before we get started, we're going to want to make sure we check our units to see what size we're working in. And so I'm going to work in feet because I'm going to do an example with a beam. And make sure your units is like 4 or 5. You're in feet and inches, and 1 to 1/32 so that it can detect tolerance. That's okay. Okay, so I'm going to start with just a simple solid beam here. And so before you use scan and solve, it uses a closed poly surface. And so to find out if your object is closed or not, if you type in SNS to open scan and solve, choose your object, it'll come up with an error, and you need to convert. You can either press yes, or we can do it another way. You can press no, and you can convert your extrusion. Convert extrusion, choose your object, press yes, and it should convert. You can determine if this is a closed polyline by typing what in, we'll say poly surface, closed, close that. And then also if you go to Analyze, Edge Tools, Show Edges, select your object, press Enter, and if you go to Naked Edges, this object is closed, so it doesn't have any. Here, I'll show you what it looks like. So if you had recurve, extrude this up, and if we were to look at it using Analyze, Edge Tool, Show Edges, we see that the top and the bottom are pink because they're not closed. And if you have a more complex object, that's a good way to find out where your error is occurring and why scan and solve won't open. We'll close that. Don't need that anymore. Delete that. Alright, and then press SNS into your command bar, and scan and solve should pop up. So in our Specify tab, we have Materials, Restraints, Loads, Resolution. So we're going to want to choose our material. I'm going to choose concrete, fairly high strength. Our restraints, you can add, go onto your object. I'm going to do the left side. And you can add more than one restraint, or you can click on this. You can edit or delete. And then we'll add our loads. Come to the other side. Select that side. And then in here, you have your option for vector force, which is like a force in a certain direction of a certain magnitude. Vector force direction and magnitude is like choosing a vector direction and then a magnitude. Scalar force is like a pressure force. Like if you were to put this on a curved surface, it would be like squeezing a ball rather than pushing or pulling. Pressure is just pounds per square feet. A pressure expression is if you want to enter a mathematical equation, like a parabola, and it will show that expression on your model. Hydrostatic has to do with water, like if you were doing a dam and you wanted to see how the pressure of the water is acting on that dam surface. And torque has to do with rotation. So let's do vector force. And let's do in the x direction, do 500 pounds. And we won't do any forces in the y or z. And if you do negative, it will change the direction of these arrows. So we'll press OK. And then resolution, that adjusts the number of elements that Rhino uses to approximate the results, so more approximate or not. And then you can also see how gravity acts on your object, like if you had an arch, you could see if it would fail or not. We're going to just press go. This takes a while sometimes.
Is it a better thing than cadre?
I hate Conquer. Alright, and so now to view your results, go into the View tab, and also if you double click on Perspective, it'll show you a legend on the side here. And total displacement is going to give you a color range of the stresses acting on your object. Deflection is going to exaggerate the deflection. You can see down here on total displacement, it says deflection scale, and it'll tell you the magnitude. Mark is going to tell you where the minimum and maximum stresses are, so if you just press minimum, it'll show you. There's our minimum deflection, maximum, here's your total maximum. And then point is you can choose any point on your object, you can do the middle here. Press enter to come back, and then clear just clears it all up. Section, we can turn that on, and that's going to allow you, oops. Oh, and if you press right click off of your, like the view, this little, into your screen here, it'll just revert back to Rhino. You just have to press scan install, choose your object to get back to this window here. So section is going to allow you to see what's going on inside of your object, to see how the stresses are acting within. You have your X, flip it, does the inverse, Y, and Z. And we can turn that off for now. Advanced is going to give you a few more options. So in our legend, you can choose whatever color scheme you like. This gives a little bit more variation within color. So this is useful for finding your compressive stresses and your tensile stresses. So if you go into min, principal stress, change your max to 0, and we can move our min line along here, and where we see blue is where our compressive stresses are happening. It's not really happening in this object because it's mainly in tensile stress because we're pulling on it. But if we go to our max principal stress, change our min to 0, we can see where our maximum tensile stresses are happening. When we reach red, that's where we get the most. So we can see that it's happening mostly at the end here because it is restrained at this edge, and so it's not deforming, it's the same, so this part is deforming the most, causing the most stress. And then we can take our findings and we can bake it into a Rhino mesh if we want to. So you just press Rhino mesh object, OK, and then change our perspective to rendered. And we're able to go into here and you can move your mesh. You can create more than one mesh with the same using different size stresses to compare. You might want to use your deflection to show the exaggeration of what's going on. If you just select your original object, type in SNS, it brings back your menu. If You can also report your object. That'll send it to a web-ready report. So if we just do that, um, it'll send you to a tab, gives you your geometry, summaries, material properties, all kinds of information you might want to use. All right, and then you can also edit your object within here. So let's say we want to restrain our object on its edges instead. So we can delete this, add restraints, and in your up here in your command line, it says linear edges. So we can change that from surfaces to linear edges. And we can choose those edges. Let me change that. Press enter, and I was able to choose more than one restraint at a time. And let's change our loads, delete that. Let's do on the surface this time. And let's see how 300 pounds acts on this object. And I did negative 300 for the negative z direction. You can see my arrows are pointing down. Press OK, and go. Right, go to our View tab. You can see how this force is acting on this object. Let's change this to total displacement. Go to our Advanced View. You can use this legend. And if we go to our minimum stress, change that to 0. Once we get into the blue, you'll see that that is where our compressive stresses are happening. And using our deflection, it becomes even more apparent and like realistic. You can do that with your max too. And once we reach areas of red, that's where our tensile stresses are happening, and that should make sense since we've all taken structures. Alright. And then we can also do apply a force in an isolated area. So if you had this beam, but you had a force acting on one part of the beam, what we can do is create a shape. I'll do a circle. It's easier to do in your top view. Choose that object, and we're going to project it on our surface. Oh. Choose your surface, press enter. Now we can go in Actually, I'm going to redo that. Circle over the edges there. Choose your object, project, choose a surface, and we can delete our original circle. Delete. And then you're going to want to split your surface with this curve. So your object is split, and then you're cutting objects. And now you have two surfaces, and we're going to want to join those so that we can use it in Scan and Solve. Now that that's been joined, we can delete that curve, and we can go back into Scan and Solve. Choose a material. Let's say that our object is restrained on this edge and our load is on just this isolated area. And -200, say go. And also, if you want to like save your results, the best way is to go into Grasshopper and change the background to white and do a screenshot, or use the that one off. Or choose the report option to send it to the web. Now we can see our result here. And then we can see how that force is acting on our object. And we can bake that if we want. Move our object, and here we can compare results. And that's about it.